Welcome to our series, Anil Gurmeen series on polynomials. I hope you appreciate our effort of promoting learning in outdoors. We are really enjoying making and creating some wonderful videos for you. Let me thank Gurmeen for seriously taking up this with a smile and pleasure. Now the idea here is to learn outdoors, get back to classroom setting, solve questions, and ensure that all what was learned has been grasped fully. So for that, on turning points, I have 10 questions for you. One by one, I'll show you all the 10 questions. You should pause the video, copy them, solve them. They're all multiple choice except for last two. And then look into my suggestions, right? So let me first share with you the first 10 questions. Question number 1. The concavity changes at the turning point. This statement is always true, sometimes true, never true. Question number 2. If the slope of the tangent line is 0 at a point on the graph of polynomial, then that will be a local maximum or minimum. This statement is always true, sometimes true, or never true. Now these are tricky questions. I've actually combined both of them in question number 3. Statement 1. Concavity changes at point A. Statement 2 is slope of the tangent line is 0 at point A. Now the question here is, point A will be a turning point if and only if which statement is true out of these 4. That's a very tricky question. I'd like you to sketch and verify. Question number 4. Least and maximum possible number of turning points for an octet, that is degree 8 polynomial, will be what? Question number 5. Write the minimum and maximum possible number of turning points for the given polynomial. Y equals to ax to the power of 6 plus bx to the power of 5 plus x to the power of 4 plus 3. Question number 6 is very similar. Write the number of turning points for the polynomial f of x equals to 5x cubed times x plus 3 whole cube times x minus 2 whole square. Question number 7. Now this is a very interesting question. Most of the videos which you have seen so far are only asking for maximum or minimum number of turning points. Now here, the question is possible number of turning points, right? So we are now looking for possible number of turning points for degree 5 polynomial can be what? 4 choices are given to you. Question number 8 is a knowledge-based question. Find number of turning points for the following functions. So I've given you a set of 5 questions. So for each, figure out how many turning points are there, right? You may sketch them to get the exact answer if the formula is not known to you. Now question number 9 here is communication question. Sketch graph of degree 7 polynomial with 4 turning points. If x approaches minus infinity, y approaches infinity, and f of 0 equals to 0. You may like to give equation also, right? So that's optional. So also you may give equation of your function. Is that okay? Question number 10. That's the last question on this topic. A polynomial has zeros of multiplicity 4 at A, 0 of multiplicity 3 at B, 0 of multiplicity 2 at C, and a linear 0 at D. So A, B, C, D are any real numbers, okay? If A is greater than B is greater than C is greater than D, then find the number of turning points for the graph of the function, right? So remember all these points A, B, C, and D belongs to real numbers, right? So that is a set of 10 questions. I hope you find them very interesting and useful. Now that actually covers quite a bit on turning points. So pause the video, answer these questions, and then look into my suggestions. Now let us try to solve them one by one. Question number 1. The concavity changes at the turning point. This statement is always true, sometimes true, or never true. Let's look into a polynomial graph, right? Let's make a simple graph here. Now, as you can see here, that is the turning point, right? That is the turning point. This is also a turning point. What do you think? Concave down, this is right. At this point, it is concave down, right? And here it is concave up. At turning point, concavity never changes, right? So concavity changes at the turning point. This statement is never true. Option C is the right option. Now, in many test papers, I have seen students making a mistake in this answer. Question number 2 is, if slope of tangent line is 0 at a point on the graph of polynomial, then that will be a local maximum or local minimum. So let's again make a graph here and then see. Now, here, what you notice here is that at turning points, we have a horizontal line which is tangent, correct? So it seems to be true. However, there are cases where, let's say, we have a cubic function. Let's take this function, right? So let's say this function, correct? Now this is a cubic function. Now here you will notice that slope is horizontal, right? But this is not a turning point, right? This is not a turning point. Do you see that? Slope is horizontal, just as in those two cases. Perfect. And therefore, even at point of inflection, where the concavity changes, the slope will be horizontal. But that is not a turning point. That is not a local maximum or minimum, right? This is local minimum. This is local maximum. This is neither max nor min. Do you understand? So this statement is sometimes true, not always true. So be careful about it. It's very important to understand this concept. Question number 3, I've actually summarized both. And now you should be in a position to answer it correctly. So what are we saying here? Statement 1, concavity changes at point A. Statement 2, slope of the tangent line is 0 at point A. Point A will be a turning point if and only if what is true. Right? So what is true? So let's look into a graph where we have both kinds of conditions, right? So let's say that is the polynomial. Is it okay? So definitely we have horizontal tangents at couple of points. Point A will be a turning point, kind of like this, if and only if concavity doesn't change. So statement 1, concavity changes at point A, is false. And statement 2, slope of tangent line is 0, is true. So statement 1 is false and statement 2 is true. Option D is the correct option. Does it make sense? Now this is extremely good question seen in so many competitive tests. Okay, now we have question number 4. It says, least and maximum possible number of turning points for octet, that is degree 8 polynomial, is what? So for octet, we have to go from quadrant 2 to quadrant 1, right? And so there is at least one turn. So that is the minimum. Perfect. Now for octet, there will be 8 zeros. That means 7 turning points, right? So we have degree 8. That means we have 8 real maximum, real zeros, and that implies 7 turning points, correct? So maximum could be 7 turning points and minimum is 1 when it is even degree, right? So that is what it is. So the answer is 1 and 7. Now here question number 5 is write minimum and maximum possible number of turning points for this polynomial. So well, let's look into the degree. So we know that the degree here is 6. Since degree is 6, which is even, perfect, so it has to turn. So minimum has to be 1 and maximum has to be n minus 1, that is 6 minus 1, 5. So 1 and 5 is the answer, right? So it's kind of similar to the previous question. Here is question number 6. Write the number of turning points for the polynomial f of x equals to 5x cubed times x plus 3 whole cube times x minus 2 whole square. Now there are many ways to do it. You could do using a formula. We have 1, 2, 3 zeros, right? So we have 3 real zeros. Now out of these 3 real zeros, one has even order. So one of them is even order. So even order means additional turning point. Do you understand? And between any 2 real zeros, we have 1 turning point. So to find turning points, we can say number of real zeros minus 1 plus number of even order zeros, right? So that formula gives us the answer as 3 minus 1 plus 1. So 1, 2, 3 zeros, so 3 minus 1 and 1 even, x minus 2, right? So that gives us 3 turning points. So the answer is D. So this is one way of doing it. Alternate method is to sketch it, right? So let me show you a simple sketch here. So we have 3 zeros. One is at 0 itself. The other one is at, let's say, minus 3, and then we have it at 2, right? So let me write down. We have 0 at 0, and here the order is 3. Then we have a 0 at minus 3, whose order is also 3, and 0 at 2 with order of 2. Leading coefficient is positive, right? So right up. So we have, in this case, leading coefficient positive, right? So right up. Now what is the degree? Just add them. 3, 3, 6 to 8, even, right? So it is even degree. So both up. So that means as far as the end behavior is concerned, both are up, right? So I'm going into this detail so that's kind of a review for you, right? Now let's begin to answer this question. Now 3 means here it will go from like this, right? Again it will cross like a cubic function. Here it is going to turn. So that is going to be the graph, and when you join them, this is how you are going to get it. Is it okay? Now these are not the turning points. Where are your turning points? Let's count them, right? So we have 3 turning points, 1, 2, and 3. Do you see that? And that's the even 0, which gives you additional turning points. So 1, 2, and 3. So 3 is the correct answer. So I hope this concept is absolutely clear. That's the key. And I hope this formula is taken note of. So I'd like you to copy this formula also as you move along this set of solutions. I hope you are enjoying this journey of learning with us. Question number 7. Possible number of turning points for a degree 5 polynomial can be what? Now, when we are talking about turning points, we don't really have to bother about leading coefficient, right? So what we're thinking here is odd degree, right? So this is odd number. That means opposite ends. Okay, so let's say this is one end and that's the other end. Okay. Now, if we have a degree 5 polynomial, we have to start from quadrant 3 and end here. So one way is to go direct, right? So how many turning points here? 0 turning point. Do you see that? Just go direct. 0 turning point. The other way could be, let's say you go from here, you take one turn. Now you have to approach that place. That means you have to take another turn. So that means now we have 2 turning points. Do you get an idea, right? Now you could also have a scenario where you could have more number of x-intercepts. After all, degree is 5, right? So you could start from here, make a turn, 1, 2, again 3, but then you have to land up there. So you have to move back. So how many turning points? 1, 2, 3, and 1, 4 turning points. So what you notice here is that odd degree function will have even number of turning points, and that is all possible turning points are 0 to 4. Now this question is very different from the first few questions where we were asking for only minimum and maximum. Remember, we could also have 2 turning points in this situation, right? So 0 to 4 is the correct answer. Question number 8. Find the number of turning points for the following functions. Now, I would like you to sketch and then get the answer, but let me give you direct answers. Now here is a linear function, right? So it's kind of a straight line, so there is no turning point. So let's write down turning points here. So for this one it is 0. Now that seems to be a parabola, right? So a parabola will turn once. So we have 1 turning point. Now what do we get? We get 3 zeros. So 1, 2, 3. So turning point should be 3 minus 1. How many even? 1 even. So plus 1. So we get 3 as our answer. You could sketch and verify. Now this formula really works very beautifully to answer such questions. 1, 2, 3 turning points, 3 intercepts, zeros, minus 1. How many even? 2 even. So we should add 2. Do you get the idea? So we get 4 turning points. And the last one here is 1, 2, 3, 4 zeros. I should say real x-intercepts, right? Or real zeros, right? Or we can say x-intercepts. Out of which, so it is 4 minus 1. After all, we have to come back. It's a continuous function. How many are even? 1 and 1. 2 even. So we'll add 2. So 4 plus 2 is 6 minus 1 gives us 5 turning points. You get an idea, right? That is how we have to get the turning points for multiple choice questions, and I think this is the most efficient way of finding. You can sketch and verify. So for you need to check this, right? So how will you check? You need to sketch and verify. Perfect. Now let's get into the last 2 questions. Question number 9. Sketch graph of degree 7 polynomial with these conditions, right? So let's sketch 4 turning points, and it also says as x approaches minus infinity, y approaches positive infinity. That means this side, right? So that is. And then f of 0 is 0. It has to go through origin also. Now degree 7 means opposite ends. So it has to land up here. That means we are going from quadrant 2 to 4. Perfect. Now when I see 4 turning points, how could I make 4 turning points? This is what you have to think about, correct? So to make 4 turning points, I could do something like this. I could have 3 x-intercepts. Then I have 3 minus 1, which is 2. And I could have 2 even order, I should say order or multiplicity zeros. So out of these 3, 2 are even orders. You get my point. 2 are even orders. That means we turn at those 2, right? So let's say we are coming from here. We kind of turn here. And then we again turn here. And then we go down, for example. So that could be a function. Now here we have 1 turning point, 2 turning point, 3 turning point, and 4 turning point. It satisfies. Is it okay? Well, that is how you could do it. Perfect. So these are the turning points. So 1 turning point, 2 turning point, 3 turning point, and 4 turning point. And that could be the graph. Perfect. So let's write down some equation for this. Let me use another ink. So let this point be at, let's say, minus 3. This is at 0. And let's call this point at, let's say plus 4. Then we could write f of x as equal to x plus 3 whole square. And here we have again turning point. And then here we could write x minus 4, a linear 0. Perfect. So you could just reorder this. Just writing x squared first is better. So that could be a possible equation. Does it make sense to you? That is how you could do it. I hope you appreciate it. The last question here is, a polynomial has zeros. Rather, a polynomial has 0 of multiplicity 4 at A, 0 of multiplicity 3 at B, 0 of multiplicity 2 at C, and a linear 0 at D. If A, B, C, D, if A is greater than B, that means A is on the right side. So that basically means on x-axis, we have point A on the right side, then we have B, and then we have C, and then we have D, right? So that is what it is. A is greater than B is greater than C. Then find the number of turning points. Okay, so you could do the other way, which is straightforward. What we are given here is 4 x-intercepts, 1, 2, 3, 4. So 4 minus 1 plus how many even? At A, order is 4, right? So this order is 4. At B, it is 3. At C, it is 2. And this is 1. So we got 2 even, right? So we'll add 2 to this. And that gives us, we are trying to find turning points, right? So it is 6 minus 1 as 5. So the 5 should be our answer. Is that okay? So that is how we could do it. Now you can see that leading coefficient doesn't really matter, right? So we could start from anywhere. So if I start from here, it is kind of linear. Here it turns. Here it is cubic. And then here it turns back again. And you get your graph. Do you see that? So you could actually connect these points and sketch your polynomial graph. And count and verify the number of turning points. So we have number of turning points as 1, 2, 3, 4, and 1, 5. Clearly, right? 1, 2, 3, 4, and 5. Remember, this is not a turning point. So we get 5 turning points as our answer. So I hope with this you have learned almost everything required on this topic of polynomials and turning points. So turning points could be local maximum or minimum. At a turning point, concavity will never change. Concavity changes at point of inflection, okay? And at turning point, the tangent is 0. But it does not mean that if tangent is 0, as x-axis is tangent to this point, it will be a turning point. No, it could be point of inflection. Is it okay? Keep these things in mind when you answer any question based on turning points and also the formula learned. Number of x-intercepts minus 1 plus number of even zeros will give you total number of turning points for the graph of a polynomial. I hope you enjoyed and learned a lot. Feel free to write your comments and share your views. And if you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.